In this last part, we'll have miscellaneous questions, including NCR, NPR, or different ways to do the counting and different tricks, skills, etc. So let's work hard to understand all of them as much as possible. First of all, it will be about a long table situation where you have five men, three ladies to join dinner. And A would be, so if there is no restriction, so eight chairs for eight persons. So that's why it may be as simple as like, because even though it's a long table, but the situation will be like you're filling up eight seats, or maybe I draw a table like this: 3, 4, 5, 6, 7, 8. Eight seats to arrange the eight persons. So that's why the easiest will be 8b8, which gives you 4-0, 3-0, totally possibilities over there. So this is the first case. Second case coming up would be now there's some restriction that three ladies must sit on the same side of the table. So because there are two sides, first row, second row, as shown in the picture, so that's why I will be dealing with the three ladies first. She has some requirement. And the first situation would be, for example, if the three ladies should be seated among these four chairs, so that's why the ways to arrange them will be 4p3, the four chairs to choose from for the three ladies. After choosing it, maybe with also, maybe these three seats, then there are 1, 2, 3, 4, 5 places for the men afterward. So the first situation would be in red as follow. The other case here would be, so the other case, because it's on, so that's it would be like the ladies are sitting in the second row. So once again, so you have 4p3 to arrange them. Maybe this time they sit together. And the next, then the men can be arranged in the 5 seats afterward. So that's why you have 5p5 finally. When you add them up, so it gives you 5760. So this is the case when you are considering two groups of people, male and female, here. Example 24 would be very like, let's see, it's very like example 10, so I leave it for you. And then example 25, the same. So you see the case when you have a 0 in your choices. So that's why I also leave it for you as a quick exercise. And the next, we have another situation like 5 boys, 4 girls in a row. In a row, that means you are having an order. So it's talking about NPR now. Next, there is a keywords talking about they are sitting alternatively, and in how many ways they can arrange the seats. Alternatively, because of 5 boys and 4 girls, then can you imagine that the only situation can be arranged would be like this: boy, girl, boy, girl, boy, girl, boy, girl, boy. Because there are one more boy than the number of girls, so that's why boy, boy should be on two sides and girl put in between two boys. Is all right? It's a very special situation. Then in this case, you will see that indeed the 4 girls will be put or be arranged in these 4 positions. So it comes to a 4p4. While for the boys, there are only 5 places for them, 5p5. So that's why this is the way how you get the answer very quickly. And now by calculator, you've got 2880 as the answer. Then you may ask, well, if there are more boys or less girls, how the question will be asked or will be done. Then we may not using alternatively. For example, this time if you have 4 boys and then 4 girls, then we'll be using a word called, for example, 4 girls cannot sit together. So you need to separate them. They can't be sit together. So in this case, then it will be a very special question because it's not just putting boys and girls in a very rigid way. Now I would be thinking the question or the skill to think of would be, because the girls should be separated, in the sitting, and that's why I will consider boys, the 6 boys, 1, 2, 3, 4, 5, 6. The 6 boys are their walls. Walls mean we may use 1 boy to separate the 2 girls, or we may be using 2 boys, or even 3 boys, more boys to separate the girl. But anyway, the boys are using as a wall to separate them. In this case, the girls can be put in more possible ways. Because the boys are using set as a wall, so that's why the girls can be substitute into the 1, 2, 3, 4, 5, 6, 7, the 7 places over there. So that's why in the calculation, girls, there are 7 positions to choose from, while for boys, there are 1, 2, 3, 4, 5, 6 positions to choose from, and then you can obtain the answer by yourselves, which is, okay, let me check, 604800 over there. Will be alright. And then example 27 is a difficult task. You can go to my notes to see the way how we can simplify NC2 over there. If you study M2, then the question is even easier, so I hope you can do it by yourselves. Next, we jump to example 28. So there are 12 students, 5 of them are boys, so I like to write 5 boys, 7 girls separate, respectively. You want to choose 5 students, and how many ways you choose 3 boys? That means you're choosing 3 boys and 2 girls, respectively. So that's why the calculation won't be very hard, because 5 boys, you choose 3, 7 girls, you choose 2, and you check from your calculator to obtain the answer. Next, we will be looking at, I would say, 29 is a hard question because it requires your special technique to deal with it. Now the 7 people sitting in a row, so that's why you should have a P and PR to talk about it. And then next, 3 of them must be, so that's the hardest word, they must sit to each other together. And then that means you are having 3 of them sit together. For example, maybe the students called ABC, they might be sitting together. It may be BAC, CAB, etc., etc. In this case, the little trick or the little technique we will be talking about will be, so we are using a block system. So what do I mean? Block system means that the 3 people should be blocked first because they want to sit together. I consider that it as a whole item. So after taking or grouping these 3 people, then they still 4 more afterward. That means now you are having 5 items to put in the 5 boxes. So is that alright? Okay, so now in this case, so that means 5 items to 5 boxes with order. So that's why it's 5P5 first. Then we settle all the 7 people now. But afterward, now we need to deal with this 3 person. Okay, the second situation will be this 3 person ABC can be rearranged to order once again. It may be like, for example, we say ABC, BAC, CAB, so and so. So once again, we consider them as, oh, I want to put them into the 3 boxes afterward. Then that's why we have 3P3, or you can write 3 times 2 times 1 as well. So both of them are okay. Then as a result, example 29 by calculator would be 720. Okay, example 28 is a miss it, then it should be the answer of 210. So finally, bear in mind that you remember this particular technique in example 29, which we use block system to talk about things or items sitting next to each other. Another example that we may consider block system may be like example 30, where you have 3 married couples, that means 6 persons, sit in a row, MPR. The spouse, okay, I highlight in this way, the spouse are to be seated next to each other. So what does that mean? That means there are 3 couples, they must sit to each other first. So as a result, we need to deal with them first. 3 couples, 1, 2, 3. Okay, they need to sit to each other. That means like putting in 3 boxes. That's why we have 3P3 first. All right. Okay, now in each couple, then so you have male female or female male, or you can consider them as you are putting in two boxes, so 2 times 1. So that's why each couple they're P21, and our couple the same, so you have to rearrange the position of them. Another P21, or at last another couple, you have also P21. So it helps you to get the answer 48 for this example. After talking about the idea about blocking the persons, people, etc., then another situation or another wording you will see in the question will be about at least, at least. So let's take a look on how we deal with the question. You want to choose 5 members from 6 senior, 4 junior staff, and that means there are total 10 people over there. And then if there are no restriction, that means a total 10 here. So you are choosing 5 members out of 10. So that's why it's 252. So because it's about committee of members, no order. So that's why we use C. Next, part B, if you want to exactly 3 senior, that means you want to choose 3S and 2 junior respectively. In this case, that means you are choosing 3 members out of 6 senior staff, 2 junior staff from 4, and that's why by calculator you've got 120. So the hardest job will be talking about at least in part C. If you talk about at least 1 junior, then you may consider several cases, which I would like to consider in this way. If you say 1 junior, that means it can be 1 junior, that means 4 senior, 2 junior, 3 senior, 3 junior, 4 senior. Sorry, not 4. It should be 2 senior, 4 junior, 1 senior. You can't have 5 junior because there are only 4 over there. So there are total 4 cases to consider, which I think it will be a bit hard. So that's why I will be consider the other direction. So besides these 4 combinations, I can have even no junior and 5 senior. So as a result, in order to have at least 1 junior, that means I want to fade away this 5 senior situation. So that's why we will use total. That means 252 we have got before, minus the case of 5 senior, because we want to have at least 1 junior over there. 5 senior, that means you want to minus 6 senior. I choose 5 of them. So by calculator, you've got 246. So this is the way to do at least. Of course, you can still consider the 4 cases respectively, but your calculation or your step will be quite long. And then at last, if you want to talk about at least 3 senior, then we may do in similar case, 3 senior, at least 3 senior will be these 3 cases. So that's why we can calculate these 3 cases one by one, or we can use subtraction as well. If you use subtraction, then we will have 252 in total, minus 3 junior, 2 senior, that means 4C3, 6C2. Last case, 4 junior, 1 senior means 4C4, 6C1. And use your calculator carefully to check whether the answer 186 you can get it or not. Example 32 will be example in past paper, which looks like example 31 a lot. I will leave it for you. And then next we take a look at example 33, which is a question very similar to, okay, let me check. I think it's quite similar to example 30 when we talk about the 3 couples. So let's take a look in this question. The question tells you that there are 8 departments. So you want to form a task group of 60 members. 2 representatives are from each department, or else to make up a total of 16. Among it, then you are choosing 4 members randomly from these 60 members. Well, it looks terrible, right? Okay, part A, there's a typo. It should be fine. Find the number of ways that the 4 selected members are nominated by 4 different departments. Definitely terrible, right? So you need some technique to deal with this particular requirement because you want to make sure that the 4 members are from different departments. So as a result, the grouping way, the blocking system may help. So what do I mean is, first of all, when we choose 4 members, we don't consider like 16C4 because it will be format C. We don't know the 4 members are from 1 department or even from 2 departments, so and so. Instead, in order to make sure that they are from 4 departments, maybe I change to green to explain the idea. 4 different departments. So first of all, you know the representatives, they are from 4 different departments. So that's why I pick 4 department circle, I can say, departments first. So it comes up with HC4 at first. So that's why in each this circle, then in each department there should be 2 representatives. Now in each department, then I will pick these 2 and choose one of them. Okay, one person, choose one of them. These 2, I choose one person. These 2, I choose one person. And last department, the same, choose one person. So that means in each department, select departments, I choose one of them from 2 of the members, 2 representatives, 2C1, 2C1, 2C1 to each of the selected departments. So this is the way how I can ensure that the 4 selected members, they are from 4 different departments, because the job is done by the step 1 as follow. It's not an easy technique, right? So that's why you need to understand it first, and later on you try the exercise to get familiar with this technique in your study. And then part B, it will be finding the number of ways the 4 selected members are nominated by at most 3 different departments. So once again, it's about at most. So that's why I will be thinking the question by listing out some possibilities first. I use yellow here. The 4 members, they can be in 4 different departments, right? So they are from different elsewhere. Then the 4 members can be from 3 different departments, right? That means 2 of them, they're from the same department. If it's pair and pair, then that means the 4 persons, they are from 2 different departments. So there won't be a case of 1 different department. Do you agree? Because that means every one of them, 4 of them, they are from the same department, which is impossible. So that's why I rub away. So this is the overall situation of considering people, the members, the different cases of their where do they come from. And then when you talk about at most 3 different departments, this is the case. We are at most, it should be at most 3 different departments. That means this is the case. So they may be coming from 3 different departments and 2 different departments, etc. So that means we are going to fade away the 4 different departments, which is 1120 at first. Now we come to look at the subject. What should we have here? Yes, it should be the total possible outcomes. Take away the 4 different departments. So this is the situation when we have at most 3 different departments. While for total, then you need to go back to the sentence, which you are choosing 4 members from 16 members. So that's why it's 16C4. And so now you use your calculator and check whether you can get 700 here. Here we come to the end of the online video lessons in permutation combination. And there are still some harder examples like example 34, 35 that we'll be going through in the lesson. Let's see. Bye.